our friend Mariam. I'm saying your name right. I think I am, right? Mariam. So pretty. Such a nice sound to it. Can you guys still hear me? Oh, cool. Okay, is that the way that you usually say it? I want to make sure I'm saying it right. Okay, cool. Cool. I just want to make sure. Cause yeah, cause gotta say it right. My grandpa, he was from Yugoslavia, and my last name used to be Marcos, but he used to get very, very offended because he is supposed to be Marcos, and from his country, it was a big deal the way you say it. So it was like a sign of major disrespect if you didn't say it right. So, ooh yeah, I get it. So I'm extra sensitive. I am. Oh man, I'm worried my writing tool isn't gonna work. Let's see. Let's try. Yep. Okay. Yeah. I don't think that's a. Yeah. Okay. So I can't write with my pen. I can do it with my mouse, but it doesn't work very well. But that's okay. Oh, no, I didn't want to do that. Undo. There we go. All right. So let's talk about radius and diameter. So this slide illustrates kind of the relationship between radius and diameter. Can you guys tell me, how do radius and diameter relate? What do you guys think? We can kind of see it from what was filled out here. Like if the diameter is 12, what is the radius? Radius is half of the diameter, right? Very good. So whatever the diameter is, and that's a really good way to kind of put it. And if you don't know that, or if you forgot it, I would write it in your notebook. I would. So radius equals 1/2 the diameter. Another way to view that is diameter is the radius times 2. Okay. Another way to view that is if you need to get a radius, you take the diameter, divide by 2. So there's a few ways to view that, but whatever the radius is, it's going to be half of the diameter. The diameter is the distance across the whole circle from side to side. It's got to go through the center, and the radius is half of that. So, oh, is that Declan? Hi, Declan. Hello, hello. Okay. No problem. I'm glad you came back. Super cool. So we were just talking about the radius and how it is 1/2 of the diameter. So when we were given a diameter of 12, we, or whoever, or Mariam, anybody who did these, they, oh, uh-oh, okay. My headphones just creaked weird, but yeah, so diameter, you cut that in half to get to the radius. Radius, you multiply by 2 to get the diameter. So very good. Any questions on that? Oh, my mouse is not gonna love things today. There we go. Cool. Okay, so we are in week 2 of quarter 4. This is our live lesson, obviously. Today we're going to talk about evaluating expressions, perimeter and area, changing dimensions. It sounds really complicated, but it's totally not. We got that.
We've made several people.
Uh-oh. Oh, I'm going to mute you, Declan, just because we're, going through stuff. And then we're going to talk about circumference and area of a circle. So this is what is due this week. You guys have pretty much like an assignment for every day, and you have the advantage of having live lesson on Monday. So we get a good overview, and then you have the week to work through your assignments. So yeah. Don't forget that all of these, like there's instruction on the Moodle pages. So let me encourage you to kind of read through that if you forget stuff. So yeah. But, oh, that's okay, no problem. But this is what is due this week. So make sure you guys get it done because it is super easy. I did have to adjust just because we had that week where school ended early. So I had to move some assignments around. So I know it looks like, whoa, an assignment per day, but usually that's the structure. But yeah, I believe next week it's a little bit better. But you want to get it done by that, latest by Saturday so it doesn't build into the next week. So yeah. Okay, we're going to talk about evaluating expressions. Okay, pretty much that's what we're doing today. You're going to be given a formula, and then you're going to be given certain values for each of the variables in there. Okay, so look at our formula here. So we have 1/2 times base 1 plus base 2 times height. This is actually the formula, one of the formulas you're going to be working with today. This is our area of a trapezoid formula. And yeah, you're going to be told what each of the variables represents, and then you'll have to evaluate it to get the answer. Why do we say evaluate and not solve? Do you guys know that? Why do we do that? Hello, why do we evaluate and not solve here? Hi, Aiden.
Hi, so for some reason, the reason I didn't come is because I saw an email that said you were sick. That was a long time ago. I thought I just got it. It was from a long time ago, and I don't even know if it was you.
Weird.
So I'm here. Sorry for being late.
Oh, that's okay. No problem. No problem. You're totally good. No problem. I'm glad you're here. But we were just talking about why you evaluate an expression. And I like what Sarah said, and Mariam, you always evaluate an expression because you have to analyze it. Okay, we evaluate because there is no equal sign. It's another thing. Oh no, you're fine. I got it. We don't spell in here. We're in math class. No, I'm just kidding. We do, but it's totally good. Okay, so we have to evaluate because there's no equal sign. And expressions are always evaluated. Whenever you see solve, you'll see that with an equation. But right now we're just dealing with expressions. So what am I going to do here, guys? If I have my formula, what do I do? What's my next step here? Here's my formula. Here are what each of the variables mean. We have to analyze it. You're right. We sure do. But like right now, my formula is telling me I take B1 and B2 and I add them together. Then I multiply by height. then I multiply by a half or divide by 2. So like, how could I start figuring out what the answer is? And remember, this is a formula, so those are lengths. Yeah, you're right. I have to plug in those numbers. Yeah, you're right. I'm going to start with those. Good job. Yeah, so our first step is we're going to plug the numbers into the expression. So instead of B1 and B2, I'm going to type in 3 and 5, pretty much. Now, my computer is not behaving. Let's see if this, yeah, so 1/2 there. It'd be so nice if I could type or like write on my screen, wouldn't it? Okay, so that's part of the formula there. Now, instead of B1 and B2, I'm going to type in a 3 plus a 5. Cool, and what am I going to plug in there instead of the H? What do I put into my formula instead of H? What do they tell me? No, they tell me what the H is. Yeah, H is height. Yeah, and how did you know it was 6? Where does it say it's 6? This sounds like a really dumb question, I know, but. And the 1/2, Sarah, the 1/2 is a part of the formula. So that will always be a half. And that's already there. We already have 1/2 times 3 plus 5. That's okay. No, that's why we talk about it, because yeah, sometimes you're so busy focusing on other things, you miss where it says it. It's okay. So it's times 6. Cool. Now let's say that you are really unsure of order of operations and all of that. Remember, we have a uber awesome website we can use called Desmos. Desmos is super helpful. So you can take that expression and you can just type it right into Desmos. We can type in 1/2, type it in just like it says it. Look at that. And you get 24. Okay, so remember, here's the link for Desmos. You always can open it up and you can put it into your bookmarks bar if you don't have it, but oh, is it? Oh, wow, I didn't know that. Yeah, I use that calculator a lot because I really like it. I always talk about it because it's super helpful there. So yeah, so you're going to plug the numbers into the expression. And then step 2, we evaluate it using Desmos or order of operations. So if I were to evaluate that using order of operations, what would I evaluate first? What do you guys think? What part of that expression? The parentheses. Yeah, very good. So I'm going to evaluate those parentheses. What's 3 plus 5? Good job, Sarah. 8. Yeah. And Mariam, good job. Yeah, and if you're not feeling 100% there with that, use a calculator. It's okay. You don't have anybody at your house judging you for like using a calculator. I use it all the time. It's all good. So cool. So we evaluated what's in the parentheses. Then what do we do? Well, we wouldn't add the 6, right? What does it mean when the H is right next to the parentheses? Multiplication. Yeah, good. Good. We're going to multiply by 6. And honestly, if you have division and multiplication left, technically you're supposed to go left to right. You sure were. So technically we would go half of 8 and then times 6. But honestly, it doesn't matter. Multiplication is commutative. You can do it in any order. So, so yeah, I would go left to right, technically, according to the rules, since there is just division and multiplication left. And then you would get, either way you do it, honestly, you get 24. So, yeah. Very good. Any questions on that? That is the process you are going to be using for a lot of your homework today. It's going to be a lot of choosing the right formula and then just plugging in the different variables. Okay, and remember, what's a variable? What is a variable? If I say you're plugging in different variables, what's a variable? Yeah, it's a letter, right? It's a letter that stands for something. So this B1 stands for base 1. B2 stands for base 2. H stands for height. And it could be any height. So, yeah, very good. All right. So guys, here are some of the formulas we're going to be using today. Okay. So we're going to find the area of a triangle, rectangle, trapezoid, parallelogram, and a circle. If you want, you can write those down. Otherwise, you can always Google it if you forget what the formula is. Oh my gosh, I'm going to show you an awesome little life hack here. I'll show you that in a second. You're going to love it. So triangle is 1/2 times base times height. Another way to think of it, if you're like me and you hate fractions, anything that you multiply by 1/2, you can think of dividing by 2. So you can think of it as base times height and then divide by 2. That's another way of thinking of it. Base times height divided by 2. That's what I usually do. Anytime there's a fraction, remember multiplying by 1/2 is the same as dividing by 2. Okay, talk to me, friends. Do I have people writing this down? I don't want to rocket ahead if I got people writing stuff down. Okay, cool. Cool. It's helpful to know them. It really is. It saves time. For a rectangle, the area is length times width. Trapezoid, people get a little more hung up on it, but all you're doing is you're adding the bases. So base 1 plus base 2. You're multiplying by height, and then you're dividing everything by 2. That's it. And then a parallelogram is base times height. A circle is pi. You got to take pi. What's pi? You guys know what that is? You probably know what that is. Because you're so smart. Pi is our, yeah, very good. 3.141592 something. Yeah, pi is a classic puzzling number. It represents the ratio of a circle's circumference to its area. Could be the other way around. I always confuse it. But it's a very unique number that keeps going and going and going. It's a very irrational number. And we use it a lot for areas. So keep in mind, Math Excel might do something where they say keep it in terms of pi, and we'll talk about what that means today. Okay, and then circumference is the distance around a circle. That's where you take 2 times pi times the radius, or pi times diameter. It's another way to think of it. So yeah. Cool, so perimeter is the distance around a figure. Area is the stuff inside. So take my rectangle up there. First of all, when you approach these figures, you should be asking yourself, what? Good. Oh, Melissa, that's so good. Good. Extra practice, right? What shape do I have here? Okay. It's one thing. What shape do I have here? And then ask, what formula do I need? Those are questions you should be asking yourself. So for the first one, we have what shape? Yep, Mariam, you got the formula, length times width. Very good. So what shape? I kind of said it, but I'll ask just because I can. What shape do I have? Rectangle. Yeah, it's definitely a rectangle. Very good. Very, very good. Okay, so to do that, I need to do length times width. So for this one, I'm going to do length times width. What's my length of that rectangle, guys? So if I want to find the area of that rectangle, I have to go length times width. Yeah, and see how Sarah says 8, Mariam says 5. I would actually say it's probably the 8, but it doesn't matter which one. You just have to multiply the two numbers. But I'm going to say it was probably the 8. But again, it depends on like how it's set up. It's really weird, but yeah. So we'll do 8, which is the length, times 5, which we're going to say is the width. What's 8 times 5? 40, that's right. And how am I going to label that? What do we have to do every time we have area with our units? And you can spell it out if it's too hard to type it that way. Oh, someone's writing it. That's awesome. Yeah, we have to square those feet. Very good. Another way to show that you're squaring something is to do like the little caret symbol above the 6 there. So very good. 40 feet squared. Good. Oh, what about perimeter? What would I add for the perimeter? If I wanted to find the distance around this rectangle, what would I add? But wait, Mariam, I only see 1 8. What? Where are you getting that other 8? Smarty Smarter's head. No. You're on the right path. That's actually a good thing. You're right. No. I didn't mean to let my sass come off wrong. No, you're good. Yeah, you were right, Mariam. Very good. Melissa says the top is the same as the bottom. So when we're adding, my point is that I was failing to make. My bad. Yeah, yeah. You can either take one side and multiply by 2, or you can remember that if one side is 8, the other side is also 8. And if one side is 5, the other side is also 5. So when you find the perimeter, you have to add everything. You're going to have to go 8 plus 8 plus 5 plus 5, because perimeter is the distance around the entire shape. Okay, so 8 plus 8 is 16. 16 plus 5, what is that? 21? Yes. 21 plus 5 is 26. Do you guys get 26? So we would say 26 feet, and you don't need to square that one. That's the perimeter. Perimeter. So it's the distance around. Whenever I hear the word perimeter, I always think of Jurassic Park. You remember the big perimeter fence? They always call it the perimeter fence. And the little boy was on there and he got shocked. Yes, Melissa, good point. You sure can do that. Another way to do perimeter is to go take one of the side lengths and multiply by 2, so you're just doubling it then. And then the other side length and multiply by 2. You will get the same answer because that is 16 plus 10, which equals 26. Nice job. Yeah, no, good question. Good job. All right, guys. What about the bottom here? This is what figure? What type of figure is the bottom? What do I have? I have a triangle, right. So that means in order to find area, I have to take the base times the height and then divide by 2. Yeah, it's actually a right triangle. You're so good because it's got a right angle. It won't change what formula we use, but yeah. And we won't be able to find uh, perimeter. Technically, you could find the perimeter if we had gone through Pythagorean theorem, but I don't think we did that. Did we do that in this class? I don't think so. I'm confusing my classes there. Yeah, if you guys are asked to find the perimeter, you'll be given the sides of the triangle, and you are not. There is a way to solve for it, but we don't have to worry about that today. So, okay, so base times the height divided by 2. So what am I going to multiply together? What is my base of the triangle that I'm given? 4, yup. So I'm going to take 4 and I'm going to multiply by the height, which is what? 9, yup. And then I'm going to divide by 2. So what is 4 times 9 and then divided by 2? 12. I think that's right. Seems might be 18. See, my brain can't. Oh, that's okay. So 4 times 9, 36 divided by 2. Yeah, that's 18. See, that's why we all check. Good job, guys. So we get 18. What's our units here? Nope, there are no units, so we're going to write the word units squared. Whenever there are no units, yeah, Sam, that works. You're right. Whenever there are no units, then you just write the word units. So, cool. Questions? Awesome. Cool, cool. Alrighty. So we're going to keep on cruising. Yeah, it is. It's very straightforward. I really like doing stuff with formulas. I really do. Okay, so we have a figure here. We know what figure it is because it's conveniently labeled. We have a trapezoid. Okay, what's one way you guys think we could spot a trapezoid? How would we know, aside from it being labeled, that we have a trapezoid? Yeah, yeah, and I wouldn't really view it as half of a hexagon because a hexagon has 6 sides. So if you're thinking half of a 6-sided figure, it would be, oh, Isabel, look what Isabel said. Yeah, Isabel, woohoo. We want to go by the parallel lines. Definitely, because we have one set of lines that are parallel, we have a trapezoid. That is the defining thing. So you guys are going to look for one set of parallel sides. Good. No, I love how people are answering, like, this is great. So, okay, so for a trapezoid, my formula tells me I have to add the bases together, and that would be the parallel sides that Isabel mentioned. So it's good to know that. Multiply by the height, and then divide by 2. That's what that formula tells me to do. So what are the 2 bases that I'm going to add together here? What are my bases that I'm going to add together? 3 and 7, good. Yeah, I'm going to go 3 plus 7. What's my height? What's my height of the trapezoid? 3. And then I'm going to divide by 2. And then it's dealer's choice. If you want to just type it into Desmos, you totally can. You can type it in. Oh, my computer is driving me nuts. 3 plus 7. And then times 3. Yeah, you could even take it piece by piece. That's 30, and then you could go 30 divided by 2, unless you can get it in your head, which is 15. Yeah, very good. Yep. Good job. Sam, I like how you put that all out there. Mariam, even with your work, that's really good. Very good, you guys. So yeah, you can use Desmos. You don't need to. You can just do the math. Just an option. So we would say our answer is, oops, I was typing that in chat, 15 yards squared. Don't forget, guys, to square your units there. Cool. Makes sense? Friends and neighbors here. Awesome. Okay, we're going to switch gears a little bit. We're going to talk about changing dimensions. Now, this part always confused me a little bit because there's just a little tweak there. Okay, now this might be confusing because you did have to go through it when we had no class. So that might be a little confusing there. Okay, so basically, when you have different figures like we have up there, okay, you're going to have different ratios for their sides. Okay, so for example, for our 2/3 figure, the 2/3 figure compares to the 4/6 figure. Okay, I wanna write it real nice. Let me see. I'm gonna grab a booklet for my mouse there. See if that helps some of the mouse sensitivity. Sorry for my mouse issues, guys. Yeah. It's a ×2 ratio. You're so right. Very good. Right. Or ×3 to the original one. Yeah. No, you're good. But we can figure out what that is. We can figure out what the scale factor is by comparing the figures to one another. And usually you'll always go big to small. Okay. But if I wanted to compare the side lengths of the 2/3 figure to the 4/6 figure, I would compare my long side to, oh, you look at that writing, it's so pretty. My other long side of the smaller figure. And I would see that this has a ratio or a scale factor of 2 to 1. Or the bigger rectangle is double the smaller rectangle. And it works that way for the perimeter too. What would be the perimeter of this smaller rectangle there? What would the perimeter be? This side would be a 2. This would be a 3. This would be a 6. 3 plus 3. Well, I think it's a little higher than that because we would have 3 plus 3, which is 6, plus 2 plus 2. No, that's okay. What would the perimeter be then? Of that little rectangle? 10. Yeah, this perimeter would be 10. What would this perimeter be? So we would have 6 plus 6 plus 4 plus 4. Yeah, that's 20. Oh, I don't want to write the 20 in there because then you're going to me, that would tell me area. So I can do the same thing. Watch what happens when I compare the perimeters. So we have 20, the bigger rectangle, compared to 10. Look at this. I get the same ratio. 2 over 1. Same ratio. Look at that. 2 over 1. Now let's talk about the area. Okay, what would the area of this figure be? What would the area of my smaller rectangle be? Length times width. What's the area of it? 3 times 2. No, the smaller one. What's 3 times 2? That would be for this one, Sarah. Yeah, you got this one. This one would be 6 times 4, which is 24. This one would be 6. Yeah, remember, guys, when we talk about area, we take length times width. So 6 times 4. No, that's okay. 6 times 4 is 24. And then 3 times 2 is 6. So let's compare the areas. 24. Oh, really? Do I sound kind of weird and robotic? Oh, I'm so sorry. I'm sorry about that. Yeah, my internet has not been the greatest with everybody being home. Yeah, watch this. Watch what happens when this reduces. 24 over 6 is 4 over 1. Look, so when we compare the areas, guys, the perimeter and the side lengths have the same area, but the area, you have to square root it to get the same ratio. So the area is always a little bit higher. So if I compared the big one, let's think of the big one here. What would the perimeter of the big rectangle be? There's 9 and 6. What would the perimeter be? 54. Well, that would be the area. Yeah, this area is 54. What about the perimeter? Yeah, we have talked about square root. Yeah. Yeah, we sure have. Very cool. What about the perimeter? What would the perimeter of that be? 39 plus 6. Yeah, totally. It totally is 30. So let's check the big one. Let's compare our sides there. So we'll compare the yep, 15 and 15. Very good. Very good. Yeah, very good. Okay, so I could even do that if I, oh, it's 3 times as big as that one. Okay, it's not working for that one. 3/2. Oh, okay, yeah, we didn't compare the side lengths. So if I compared the side lengths of this one, I could even compare like between the blue rectangle and then the green rectangle. If I compared those side lengths, I would get 9 to 6, which actually has a little bit different scale factor. If I divided by 3, I'd get 3/2. Now I can compare the perimeters. Works out the same way. 30/20, which is also 3/2. But then if I compared the areas, I would have 54/24. And I divide by 6 for that, that would give me 9/4. So see how the areas are always doubled or squared of whatever the perimeters are. So if you're ever given this question, and I'll show you what that means. I'll show you what it means for your homework and stuff. You always have to square root it. So for example, you're going to be given 2 figures here, and you're going to be asked to find the scale factor. Okay, so we would compare either the big to small or the small to big. Does not matter which way. So let's compare the big to the small. So if I compared the big parallelogram to the small parallelogram, what fraction would I end up with for the scale factor? What is the ratio of the big side to the small side? What do you guys think? What's the length of the big side of my triangle or parallelogram? What's the length of my big side of my parallelogram? Well, this wouldn't be a trapezoid. You're right. It's got a set of parallel sides, but it also has this set of parallel sides. You sure can, but all I want to know right now is what is the length of the long side or the big side of our parallelogram? What do you guys think? What does it tell me the length of the long side of the parallelogram is? What does it say, guys? 12 centimeters. Yeah. Yeah, it says 12, right? So the length of the big side is 12. The length of the small side is 9. So what does that reduce down to? What is 12 over 9 reduce down to? And this is what you would be asked in your homework. You would be asked to compare the big side to the small and leave it as a fraction. They want it as a fraction because they want to see big to small. What does that reduce to? What could I divide that fraction by? 12 over 9. Is it? Or could you divide by 3? What do you think? I think you could divide by 3, yes. What would it be? Yeah, what do you think it would be? Yup, if you divided by 3, you would have 4 over 3. You sure would. And then they're going to ask what would the ratio of the perimeter be? And the ratio of the perimeter is going to be the same as the side ratio. So if we compare the big to the small, the perimeter is going to work the same way. But if I want to get the ratio of the area, that's where you would have to square it. You would go 16 over 9. You would have to square. Oh, yeah. No, and that can be confusing, but sometimes when you divide by 3, there are some weirdo numbers there. But guys, what I want you to focus on, if they ask you for the ratio, for the scale factor, that's what we just found. The ratio of the perimeter is exactly the same as the scale factor. But when you give the ratio of the area, you have to square either the scale factor or the ratio of the perimeter. Does that make sense, guys? You have to square what it is. Okay. That's all I want you to do. Okay? Square that. What about the rest of you guys? Are you still with me? Did I lose you? Yeah, go ahead. Make sure you square it. So if we had like just a different example here, let's say this side was cool. Let's say this side was 20 and this side was 5. If I wanted to give that ratio of the scale factor, I would go 20 over 5. That's comparing the two side lengths. The ratio of the perimeter would be exactly the same, but if I wanted to give the ratio of the area or how the areas would compare, then it would be a lot bigger. 400 to like 25. You got to square them. So whenever they want that ratio of area, just square the other one, meaning you multiply it by itself, right? When you square something, you multiply it by itself. Yeah, this one, I feel like it's confusing to explain personally. But any questions on that? If you have no questions, go ahead and click on your participant list. One, two. About ratio and area. Yeah. So like what the reason that we do it like that, and I'm just going to see if okay, here we go. Cool. This is a good example. So right now, they are giving me it says find the scale factor and ratio of perimeters. So ratio of perimeters means you're comparing the sides. Okay, so, and if they give us, right now they gave us the ratio of areas. So they're saying 25 centimeters squared and 4 centimeters squared. So what they're doing is they are comparing the big trapezoid to the small trapezoid. And the reason they might do that is because when you have that scale factor, it would help us find missing measurements. So with a scale factor, we can say if one side is 9 centimeters, the bigger one would have to be this many centimeters. So they're giving us the area one. They want to know what the scale factor would be. So what I would do is I would take that 25 centimeters squared multiplied. Oh, yes. Got it. Okay. I get what you're saying, Mr. Sam. So they are saying to take the scale factor of the areas that they are giving you. Okay, so this is what they gave us. They told us 25 to 4. Another way of seeing that is 25 over 4. But if I want to turn that into a scale factor, I have to take the square root. Because the area scale factor is always squared. So what is the square root? Oh, yeah, we'll be done after this question, I promise. What is the square root of 25? So what was squared to give me 25? 5. 5 was squared. And if you don't know that, Desmos is a very helpful tool here. We can go to Desmos. Oops. We can go to Desmos and we can type in, right? That was pretty cool. We can type in, hit enter, type in the square root of 25. You can move your cursor there, divided by the square root of 4. You can type it right into Desmos. You will get a decimal, and they don't like decimals traditionally, so you just click on this little circle to convert it to a fraction. 5 over 2. Does that make sense, Mariam? So if you have the scale factor of the areas, all you got to do is take the square root to get to the scale factor. So we take the square root of each, we get 5 centimeters over 2 centimeters. That would be the scale factor. And then the perimeter is the same one. Perimeter works the same way. So the same answer works for perimeters. So 5 over 2, you just take the square root. That's it. Or if you have the scale factor and you want to get the ratio of the areas, you square it. So I'm going to have you chew on that for a little bit. That sounds really weird the way I said that. I apologize. So yeah, so I'm going to stop for now here. I'm going to post a video going through circles and area and all of that stuff just because it's 11. So we got to go. But if you need anything or if you're confused, oh my gosh, just text me. I will help you. Seriously. So yeah, I got all your stuff graded, so you can go in there and you can